Hello, in this video I'm going to talk about the SD7 and the Rafale. This is the SD7, which is basically a miniature version of the Rafale. Got the exact plan form as the Rafale. Same chord width at the root, just a shorter wingspan. This smaller glider was developed as a cheaper option and a more convenient option also for just a park flying scenario where you want to carry your glider in your car for easy transport. You just leave it as a one piece and it fits in the back, on the back seat or in the boot, and it performs really well, nearly as well as the Rafale. Launches as high, obviously because of the reduced wingspan. The efficiency is slightly lower, but really it was surprising how efficient this little glider was in comparison. Just going to touch on the radio setup for the Rafale, which is nearly identical to the SD7. On this model, I've opted not to use a rudder, but it's there. You can have it. You can order a rudder hinged or not. I've always flown with just elevator, servo, and ailerons, so only 3 servos required. But there's enough ample space in the pod for 2 servos. So coming to elevator movement, all the control surfaces I enjoy using quite a bit of exponential, like about 50%, just to add a bit of smoothness to the control inputs. You'll notice, especially when there's not much wind and there's no turbulence, you'll pick up on these little differences. So if you're a little bit aggressive on your aileron inputs, you'll see the glider has got a little bit of adverse yaw. So it's better to have a smoother input. That's why I like exponential. The elevator is adjusted so that the maximum travel reaches and touches all the way to the boom. And you'll notice also when I apply elevator, I've included what we call snap flap. So that means down flap when you pull up elevator, and it'll go up flap when you push down elevator. So the reverse. And this really helps with pitch control. The responsiveness is that much better. So instead of increasing camber in your turns and that to make it more efficient, it's an automatic feature. So I also, for the different mode setting, flight modes, I like to use a throttle stick to change it instead of a switch. A lot of people opt for a 3-position switch for different flight modes. I prefer constantly playing with the throttle settings here. And what I've done is throttle all the way up. Gives me a little bit of reflex, so that's in speed mode. It's about a 2mm up movement here. And for cruise, which is the stick in the neutral position here, the ailerons in neutral position. And then for thermal or hang time, like a minimum sink setting, we'll have about 2 or 3 millimeters of down flap. Then what else can I say? Yes, for landing, because so now I'm going landing mode. Obviously, it will give a lot more flap deflection, but because I'm not using a rudder, the way I've set up my flaps is to pick up one or the other. So this kind of setup is quite aggressive and it gives you a lot of control on landing. Okay, so that's basically the radio setup. I've got also a switch linked for launch mode. So during launch, I give a little bit of up till the glider reaches the correct angle of trajectory, and then I release it. But you'll notice also for this glider, I've included a little bit of right input, which is the left aileron goes down slightly, but this is minuscule. It's about a 1 millimeter change, and it made a huge difference on the launch trajectory. So it's a little bit of right input, right roll input on launch. And what this does is, I don't know why it seems to help on my particular launch style, because it's quite whippy, and I tend to hook a little bit. So this helps with that. And I'm guessing that if I had a rudder, I could also include a little bit of right rudder. A lot of people do that. So including with up elevator, you would have a touch of right rudder. So it will help correct the glider on launch. On the airframe side, talking about a few things, you've got the tail fin and the stabilizer, which is made from Airx and carbon fiber, and the skins, it's got a carbon fiber leading edge, which can take a lot of knocks. It's very durable, and it's covered in 25-gram glass and tissue paper, like a black tissue paper, which gives a lot of stiffness to the structure. You can take a lot of side knocks on landing. And the tail is bottom mounted here on this little pylon, and the boom, I end up with this smooth finish on the boom because it's a rolled, the way I've manufactured it, it's rolled, and it's got one seam at the bottom of the boom. The elevator is under spring tension here, so it's just using a pull cable, and the same will apply with the rudder. So if you order a rudder, hinged rudders, you'll have also a spring-loaded system similar to this with the control horn. The reason why I have the control horn external instead of inside the boom is for easy access, so you can pop off this from the slot here. So when you remove the boom for transport, this just pops off, and the cable runs along the side of the boom on the outside. Because the way this design works is the wings are glued and slotted into the pod here, so there's a permanent structure. But from this point there's a shaft that comes up to right here, and the boom slides off. So what you'd have to do is just remove this self-tapering screw. That's just a locating thing, just to keep the boom from twisting on itself, to prevent it from twisting on landing, and so forth. So what else? Yes, so it's a full carbon pod. So one thing to keep in mind is that the antennas need to stick outside the pod. There's been, I don't know, I've put quite a bit of thought into the launch pegs. The glider comes with two launch pegs, one for left hand, one for right hand. So it's optional, obviously, to put both. I've put a little bit of thought into the design and the general styling of it, because I wanted it to look a little bit like a winglet. So it's got a little bit of sweep back. So obviously the same peg won't be able to function for both left and right. So they come separately with the curvature on it, and the curvature is there just to help prevent the bottom finger from sliding off, especially when you start relaxing. That finger tends to slide off, so that keeps it locked in place here. And I feel that the sweep back design on the peg tends to line up with also where your knuckles bend here. and I find it very comfortable, this, and it also looks good. So that's something, a new feature I've been working on. Moving on now to the SD7, which is the smaller version of the Rafale. This model is quite convenient, just to throw in the back of your car or your boot. It's small enough with a 1.2 meter wingspan. So it's nearly identical to the Rafale in plan form. It's just the cord is the same. It's just a shorter wingspan. And this model launches as high. I'm reaching 55 meters comfortably. And it's got a decent hang time. Obviously not as efficient as the Rafale because of the limited wingspan, but still a very good all-round model. I chose to use some small microservos for this model just to keep the weight down. They're 5 grams each, and they're not very powerful. They're only 0.8 kilogram, and they're quite inexpensive servos, but they work very well. As long as you use you need to use the hole that's closest to the pivot point on the control horn just to maximize the torque of the servo. But it's powerful enough to fight against the torsion spring of the elevator. And here you'll see that there's a spring steel, 0.5mm spring steel that goes through a Teflon sleeve. Coming out the top here by the aileron, and it's just bent over, and it's actually quite stiff. Anyway, there's no flutter with using these small servos. One thing to consider is just to fill up the hole here that the push rod goes through, because it's probably a 1mm hole or so. You need to void fill that with a little bit of Sino, just to prevent slop. Another thing to point out is how the pull cable just hangs out the outside of the fuselage here, runs along the boom, but it just pops into the pod here behind the canopy and runs on top of the receiver. You can go a little bit more in line with the boom if you like, depending on how you install things. The servo also is easier mounted. If you're installing any servos in the pod, it's good just to put a little mounting block just to raise the control horn off the skins here. And keep in mind that the antennas have to be outside the carbon. For this model, I didn't need to actually preset any kind of up elevator input on launch or roll input. If I flick the switch here, nothing's budging for launch, because I think it's slightly stable, this glider. It's got the center of gravity is about 68mm from the leading edge. So as you move it back to about 70 by the rear spar here, when you're reaching to about 70mm, it starts becoming CG neutral, and that's when you need a bit of up elevator. But if you go slightly forward on the CG, you'll notice that the glider rotates with the excessive airspeed on launch. It'll just rotate to the right angle naturally. So it does simplify things if you want to make life easier on launch. I'm just a habitual thing for me, so I'm always programming the switch on all my models. And on this model, because of the short wingspan, and even though there's no rudder, I don't also bother with roll input on launch. It doesn't seem to require it. whereas the Rafale needs about 1mm offset on launch just to keep things dead straight. So I'm going to demonstrate how to remove the boom from the Rafale and the ST7. The first thing you've got to do is remove either the rudder control horn and the elevator, or just the elevator control horn. So I'm going to try and demonstrate here while holding my camera. There's a slot here, so you just got to lift up the elevator and pop that off. There we go. So now you've got your cable that's loose here, dangling. So move that out the way. And then now the next step would just to be remove the locating screw. So there's no point over tightening the screw. It's just a self-tapping screw, and its purpose is just purely to stop the boom from sliding, twisting left and right. So as you can see here, when you assemble the glider, you're going to try and line up the tail to be horizontal with the wings, and then once you're happy with that, you'll just drill a hole and just stop it from twisting on landings. So again, let me see if I can remove it while holding the camera. There we go. So that slides off the shaft like so. You can see the other hole, and there we go. So when you want to transport the glider, you're left with this kind of look, and you can obviously remove the tail as well, these two bolts.